Good evening, everybody. My name is Sven Löschner. I'm studying applied computer science at the Ruhr University Bochum. At the moment, I'm writing my bachelor's thesis at the chair for network and data security. Together with André Adelsbach and Ulrich Grevler, I'm working on the project that I'm going to introduce to you in the next couple of minutes. I will present you an approach how to make anonymous broadband broadcasts by misusing a satellite internet service provider account. At first, an overview of what you can expect during my lecture. How you can see, there are two main parts. At first, you will obtain an introduction about internet via satellite, what it is, how it works, and so on. After that, we should have the basic knowledge for the second part, where I will explain our approach to misuse a satellite ISP account. At the end, you will have, I hope, enough time, but I think so, enough time to ask questions, which I will try to answer as good as I can. So that's for introduction. Everybody knows artificial satellites. At the moment, there are a few thousands of them out in space. Because you can't see them with the bare eye, people often forget their importance because they can't see them. But if these satellites were gone, we would all realize very fast. Because satellites are specialized wireless transmitters placed in terrestrial orbit for diverse purposes, such as weather forecasting, television broadcast, radio communication, internet access, and global navigation systems like the well-known GPS. Satellites can receive and retransmit thousands of signals simultaneously, from simple digital data up to complex television programs in HDTV quality, for example. Especially in low infrastructure areas, like the one in the picture above. They also provide an interesting alternative for high-speed internet access because they provide high data rates and they cover very large areas with comparably low effort. One big advantage of services via satellites is the big choice of services you can choose from. So you do not buy hardware that you can only use for accessing the internet, but also for receiving radio or television programs. The hardware parts you need are a satellite dish and a digital LMB, which is the head mounted on the top of the dish arm. At least you need a receiving device, like a digital television receiver, or in our case, a digital or a DVB-S card, digital video broadcast card, mounted in our PC. Now at first, a little bit more about internet via satellite. There often comes up the question how the data is filtered or delivered correctly to the person when it is broadcasted. Television broadcasts, for example, are mostly not addressed to one single user, so you don't have to care that much about addressing. But when, for example, a user wants his satellite ISP to send him his personal emails, he wouldn't be amused if anyone else in the satellite's footprint could receive and read these emails. So the trick that is used is mostly a unique MAC address on each DVB-S card. This MAC address is encapsulated in each file header that is sent to the user. This is not the only, but the most used way data is marked and later identified in satellite broadcasts stream. There are two kinds of internet via satellite which must be differentiated. The first form is the one-way variant. In this one, the satellite only handles the downstream to the user, with the outbound data traveling through a terrestrial return, mostly a telephone modem, taking care of the low bandwidth traffic from the user to the ISP. Most users only desire a high download bandwidth, while they would accept a rather small uplink capacity. So this hybrid solution would satisfy their needs. The other form is the two-way variant. Here the user has got a satellite transmitter unit on his satellite dish that enables a two-way communication with high bandwidth in both directions, such as up and downlink. So the terrestrial return is not needed anymore. As a little note, the uplink bandwidth is much higher than the one-way variance one, but it's still smaller than the downlink bandwidth. The big disadvantage of the nice two-way variant is its very high cost, which make this form of internet via satellite only suitable for companies connecting their remote branches to the data network or so. In our work, we focus only on the one-way variant because it is more common, or it is more common for standard users today. However, we want to stress that our proposal is even more suitable for two-way satellite communication, as the ISP has to broadcast all packets via the satellite downlink. To illustrate how the one-way satellite variant works, consider the setting where a user wants to download a video file from a web server. He establishes a small bandwidth dial-up connection to his ISP, e.g. using in Germany an ISDN line, and in order to initiate the download, his request is sent through the dial-up line to an ISP proxy server, which relays the request to the desired destination address. The reply coming from the server, hopefully our requested video file, is rerouted by the satellite ISP so that it will not come back through the dial-up line. Instead of this, it is encapsulated with the user's MAC, or sometimes the IP address, into a signal based on the DVB standard. And this signal is relayed from the satellite, from the ISP's ground station to the satellite. The satellite now, on his part, broadcasts the data back to the user or the users who is running a piece of software on his PC which completes the TCP communication transparently to the application or the operation system. But due to the broadcast character of the satellite, the signal dedicated for this user can be received by anyone in the footprint of the satellite. This can be done by setting your DVB-S card into so-called promiscuous mode. This means a mode of operation the DVB-S device is able to receive and read every transmitted data packet. Not only its own ones. So it is, or it would be, or it is very easy to read files dedicated to other users when there's no encryption. Now, that were all the basics we need for our solution. So here a direct comparison to the graphics shown before. We have a sender who is an official client of the satellite ISP. He wants to share perhaps his holiday video with some friends, our receiver. This receiver is not an official client of the ISP. He only has got a satellite dish and a digital video broadcast, a DVB-S card. So the basic idea means the server pushing the data and a special mark onto the server. For this upload process, he might use any type of connection. After that, he requests the data from his satellite ISP. The ISP relays the data, as he had done before, to the server. And the server now transmits the data again, but with a header modified with our special mark mentioned before, so that this packet can be identified by everyone who knows this special mark, so you can filter for it. The satellite later now broadcasts the data as it also done before, and our receiver now looks for packets with the mentioned special mark. This is the rough scene how it would work. But before getting more detailed, I would like to make a little insertion about what are anonymity and pseudonymity. Both are often mentioned when people talk about things like sharing files over or through the internet. And anonymity is mostly defined as the state of being not identifiable within the set or within a set of subjects having the same attributes. In anonymity of communication, you've got to take care of both sides. You've got the anonymity of the sender and the anonymity of the receiver. In our case, the sender's anonymity set are the online ISP users. The receiver anonymity is much higher because the set consists of every household with a satellite antenna. Pseudonyms in this way are not anonymous. They are often used to identify. So for example, our special mark given with each file header would be a pseudonym. This is just for understanding the following better. So now we should take a look what the whole project should be able to do at the end. We want to send data with probably low costs to a defined set of anonymous receivers. Additionally, we want to protect our files so they cannot be read by other users who, for example, are also listening on the broadcast in promiscuous mode.